So first of all, thank you so much for having me to present my work on PyData Seattle. It's a great feeling. Tonight I want to talk about something that I'm really passionate about and something that's very dear to me. And this has been not a project, I'll say it is more of a journey. And before I give you some pointers, I would at least would like you to take you along this journey and help you understand the problem, the use cases, and how I worked on this problem and how you can also maybe do some from your own home. Okay, now, so tonight I'll talk about three letters which I felt were pretty commonplace, but it turns out that they are not. And these three letters are ISL, which stand for Indian Sign Language. It's for people in India who are deaf and mute and who don't have the ability to communicate. So can we do something or build something for them? And this is my journey. So let's get started. Before I do that, here's an important thing. So if you want to look at the slides, you can go to bit.ly/ISLAR23, or you can just use your phone, get a camera, and then use this QR code to directly go to the slides. And these slides will have a little bit of the video involved as well. So it's always great to just look at here and then maybe perhaps if you want, you can go back home and take some pointers from the slides. Something about myself, I just graduated from Carnegie University. I'm currently working at Yahoo. I have been invited by Google to present my work on sign language, which I will talk about in more details in a couple of minutes. I have my tutorial accepted at IEEE conference in computer vision. I have been awarded at Intel Top Innovator Award in 2019, delegate at 2020 Harvard College Conference, and have given multiple sessions on machine learning and AI. So I'm hoping that you guys are in good hands. But before we go, because it's a journey, I want to talk about myself in a few slides so that you guys get an understanding of where I come from, the things that I really like. So this is me in my bachelor's. This is a college in Pune. This is me playing the guitar and my friend who's singing. This is part of our cultural fest that happens every year. Then I started working as a data science engineer at Lowe's Technologies. We used to make search and running applications for the Lowe's home improvement website. This is me from the team. Then I came to CMU. Here's me studying started my college at Carnegie University. And then finally, I am doing work in recommendations and machine learning at Yahoo. So I recently got my poster published at Yahoo conference, so I'm really happy about that. Alright, so now that we have the background set, now you guys know about me, you guys probably relate a bit more to me. I want to talk about my motivation, and this motivation comes from a video that I saw in 2018. It's about a person whose name is Tanya Finlayson, and she had no motor motion from her neck down, so she's basically paralyzed from her neck down. And this is her journey. It's going to be a short video around 2 minutes, which explains how she used her skills to help Google use Morse code in their own Google keyboard. So let's have a look at the video, and I hope you guys take something towards the end of this video.
Hi, I am Tanya. This is my voice. I use Morse code by putting dots and dashes with switches mounted near my head. As a very young child, I used a communication word board. I used a head stick to point to the words. It was very attractive, to say the least. Once Morse code was incorporated into my life, it was a feeling of pure liberation and freedom. See you later. I think that is why I like skydiving so much. It is the same kind of feeling. Through skydiving, I met Ken, the love of my life, and partner in crime.
It's always been very, very difficult just to find Morse code devices, to try Morse code.
This is why I had to create my own. With the help from Ken, I have a voice and more independence in my daily life. But most people don't have Ken. It is our hope that we can collaborate with the Gboard team to help people who want to tap into the freedom of using Morse code.
Gboard is the Google keyboard. What we have discovered working on Gboard is that there are entire pockets of population in the world, and when I say pockets, it's like tens of millions of people who have never had access to a keyboard that works in their own language. With Tanya, we've built support in Gboard for Morse code. So it's an input modality that allows you to type in Morse code and get text out with predictions, suggestions. I think it's a beautiful example of where machine learning can really assist someone in a way that a normal keyboard without artificial intelligence wouldn't be able to.
I am very excited to continue on this journey. Many people will benefit from this, and that thrills me to no end.
Alright, thank you so much for watching that video. This video served an important motivation point for me. I watched this video back in 2018. This was part of their Google I/O summit that happens. And then that's when I realized, okay, it's important to find problems in your community and help solve them using technology. And that's when I realized the true potential of technology and how we'll be using it. Okay, let's talk about ISLAR now, Indian Sign Language recognition. But before we do that, let's talk about Indian Sign Language. So, based on the statistics, around 18 million people in India have speech and hearing impairment, which is around 1% of the population, less than 1%. Since India is a diverse country, there are different languages, different dialects, different people. The sign language also changes, and this is something that I realized while working on this project, that the sign language within India is not universal. And that makes it much more difficult for a system to incorporate everything. And finally, sign language is not an official language. It is still considered as a skill in India. And when something is not an official language, the government is not entitled to, or does not really have to give it means to make sure that people feel included. Now, based on data from 2018, only 250 certified sign language interpreters exist in India, although I'm assuming that this number is going to be more, but these are the actual certified interpreters. And then based on a survey, only 30% of the specially able people are able to receive help in India. And this is something that I find pretty interesting in the US, that there's always room for accessibility, room for inclusion, and one of the reasons why I was enamored by US was when I came to Pittsburgh. I saw all these road signs, all my university lecture halls had braille, had inclusivity, so that people from who are not who are specially able can also feel inclusive. Alright, so let's talk about sign language and what I wanted to do. So I wanted to develop a sign language recognition system that uses AI to generalize sign language across population. So, for example, if you move across different areas in India, at least it should be able to get subtle nuances and understand that and help solve them. And then I also want to keep the resource to a bare minimum. They don't want to depend on GPUs or expensive hardware. Want to develop this solely on CPUs, and it can be deployed on mobile phones, which can be easily accessed. Now, the methodology that I follow, and this is true for any sign language, is you can classify that into 3 categories. So the first, if you are able to get the hand gestures, right? Sign language is all about hand gestures. If you are able to correctly identify them and maybe classify them, you can get what the sign means. Also, facial expressions play a very important role, where different facial expressions could mean different things in sign language. And then finally, pose estimation. This would make it like complete thing, but even if you get the first 2, you can solve around 90 to 95% of the problems in sign language in India. Alright, so the journey that I thought that I will take is, I thought that I will just go to an NGO, build a model, and then go probably build the production. But this is not what happened. So when I went to an NGO that was near my place, I first interacted. For the first 6 months, I just spent learning sign language, interacting with the people, understanding the problems that they had, and how people are helping how the daily challenges that they are facing. Then I formulated a problem statement where okay, I broke the problem into different pieces and tried to solve each one at a time, and then I had to go back, iterate, get feedback based on my interaction with the NGO, with the teachers, then get expert feedback. Luckily, I was lucky enough to have good connections all over the world. I talked to a professor here at in NYC who mentioned that ASL or American Sign Language is universal throughout the US. So even if you go from California to New York, Michigan, Ohio, sign language remains the same. So that makes it easier for something to be built scalably. But in India, that's not the case. And then once the solution was there, I verified it, gave it back to the sign language community in India and asked for help and wanted to understand if my solution is good enough for the problem or not. And then finally deployed that to production so that it can be used by people in India. So this is another video which I will not play. This is some of my friends from the Sign Language Institute. Both of them are deaf and mute, and they help me understand the problem and build training data set for my algorithm. So I'll not play it for now, but you can have a look at that once you look at the slides. They help me understand different signs for different alphabets, different simple gestures, just so that I can build my application later on. So I decided to divide my application into different versions or different phases. So the first phase was the easiest one. I just wanted to see if I could actually develop something like this or not. So for the first phase, I just went with the hand gestures. So here you can see these are different hand gestures for different digits. And then I moved on to different alphabets. So from one hand, in version 1, we had digits were mostly in one hand. And then alphabet, they used two hands. And as you can see, I am using image processing techniques to just work with a skeletal image, not the actual image. So I'm reducing noise and making sure that my algorithm can be flexible and lightweight so that it can work on different phones and edge devices. So here's a short snippet of how it works. So I use a small trick. I am wearing blue colored gloves, and then doing color segmentation on it. And on the right, you can see that I am not working with the entire image, just working with just my hand gestures. So this makes the image lightweight, and it helps me only work on the part of the image that actually has the object. So this made my algorithm fast. Not the best way of doing it, but I just wanted to see if I could do something like this in a short span of time. Then I moved to version 2. Version 2, if you guys remember, talks about facial expressions. So I had a different model that used to capture facial key points. So I'm tracking different key points. Let's look at the video. So in this video, you can see that I'm tracking my eyes, my nose, my lips, jaw, and again my hands. And then there's a bounding box around it just to make sure that all the data that I'm working with is just the subject that I'm looking at and not the entire image. And this helped me not only keep my model lightweight, but also the noise from the background can sufficiently corrupt the model if your model is not well trained. So I just tried to do that, and I think it worked well and giving answers or gestures in real time. So right now version 2 is still only static gestures. So as you can see, I'm using each frame and then running an algorithm and getting each prediction across each frame. This may not be the best way of doing it, but it was good enough for me to get started. Okay, let's talk about 2.1. Then I thought, okay, I'll add voice to it. So I use a simple Google text-to-speech.
Hi.
So basically, for each gesture, it gives you some sort of
Understand.
audio feedback, very minor adjustment.
Study.
But then with version 3, then I tried to combine different parts of different frames. So I took a screenshot of 10 seconds worth of sign language, that was a static number. So for 10 seconds, my algorithm is going to analyze all the frames and then gives a meaningful answer. So let's just have a look at this particular video. So I'm trying to do 3 signs or 3 different gestures in 10 seconds.
Where is the food menu?
So these include just some of the basic phrases that people might use. For example, I'm not feeling well, where's the doctor, and things like that. So I experimented with around 20-25 different simple gestures, and then the results were pretty positive. However, a better algorithm would be to have some sort of sequential model where, in case of normal words, how we communicate is that right now we are having a communication. Like I'm able to speak because you can get a sense of what I'm talking throughout the entire sentence and maybe throughout the entire paragraph. But the algorithm that I developed mostly took static images or static data and then tried to predict on each frame. But an ideal way should have been to use maybe a sequential model where you are passing context from the first frame to other frames as well, and then forming the entire sentence or the entire paragraph and not just 2 or 3 words at a time. But it worked well. It helped me prove a point that okay, this problem could be solved. And I was lucky enough. I will not play this video, but you can have a look. I was lucky enough to be invited to Google in California in 2019. I was in India at that time, and there was a conference that happened for the expert group in Google in India. I was part of that, and I got a chance to come here. And remember the video that we just saw about Tanya Fination? That was my motivation. And then after this conference, I think I got some good reviews. Google decided to actually do a video on the journey that I followed. So I'm just going to play that. It's again 2.5 or 3 minutes. Have a look at that, and we'll then proceed forward.
I come from a small family, currently staying in Mumbai. My father and my brother are working in finance department, and they wanted me to do the same. But I always believe that my passion is coding. Usually in Indian family, what happens, the father is considered to be the real boss, but in actuality, the mother is the real head of the family. So once my mother is convinced, convincing my father is pretty easy for my mother. When I joined university, I wanted to explore as a person who I was. So I did a lot of things other than computer science. And in 2018, I saw a video by Tanya Finlayson at Google I/O. She helped Google's keyboard team to integrate Morse code into their Google keyboard. And that is something that really inspired me to affect people in a positive way. After graduation, I started volunteering at a deaf and mute institute near my place. After 5 to 6 months of spending time learning sign language, I was still having problems communicating with them effectively. That's when I realized that somebody who does not know sign language will have a lot of problems communicating with a deaf and mute person. I wanted to use TensorFlow and machine learning to get the images in real time from the camera and then translate them to speech. So basically it was gesture to speech. As any machine learning researcher will do, I searched on the internet for similar datasets. Although I found relevant datasets, these were not that I was looking for. Therefore, in the end, I decided to make my own dataset. So I wrote a Python script that was continuously recording different gestures, and at the same time it was filtering out the background noise, and I was just saving those skeleton images. I showed this initiative to my friends and they were pretty excited, and they ended up spending a lot of time with me on collecting the dataset. So I used Vision API to make my images a bit more clean. But even after doing that, my machine learning model was not performing up to the mark. This is when I realized that with using sign language, you don't have to only depend on the gestures, but your facial expressions also play a very important role. Me and my friends, after this, we went and took thousands of photos with both hand gestures as well as facial features. Of course, my friends were quite upset with me, but I think another pizza really kept their motivation up. Before incorporating facial expressions, my machine learning model was just predicting letters and numbers. After adding facial expressions, I could incorporate for much more wider gestures like being scared or being confused, or if you understood something, you could do it very simply. So this really helped my machine learning model appeal to a wider audience.
I did not feel good.
Machine learning and TensorFlow helped me build a sign language solution for the communities in India. I believe that using the same technologies, people all over the world could solve issues for their own community.
Alright, thank you so much for watching that video. I had a great time making this video, but apart from that, I had a really fun time spending around 18 to 24 months where I used to volunteer at the NGO, understand the problem, and then help build a simple solution for it. But now comes the question: how can you help? Okay. So the first and the most important point that I feel is awareness. To be honest, I was back in India. I was not aware of the issues that especially able people feel every day in India. So just talking about something, at least addressing the issue, solves half of the issue. I was not aware that sign language was such a major problem in India, and that sign language was not universal. I thought that it should be universal and it should be taught to students like how we teach English or other languages, but it is not. But having that awareness helps us to move ahead and solve the problem. Second is you can find this petition. You can go to the my slides and there's a link to a change.org petition, which petitions this sign language should be made into an official language. It's currently a skill. Third, you can volunteer. I actually was at a low point in my life when I started volunteering at an NGO, and it helped me recover. It helped me feel motivated. It gave me a purpose, and also it's a lot of fun. And finally, you should learn the language if you really feel passionate about it. If you learn ASL or ISL, that doesn't matter. At least have some knowledge. It really helps when you communicate with people. So that was almost it. I will talk a bit about my own interests. So I am the kind of person who likes to get different passions and mix them together. So I also play the guitar. You might have seen in one of the photos. So I use a simple hand tracking or hand gesture recognition to use with my guitar. There's no sound to it right now, but then you can probably use this to help teach guitar to younger audiences. Then I also played around with how you can use machine learning and computer vision to make your workouts more fun. Then I also did something for a game called cricket, which is pretty popular in India. It's like American football or soccer, but just for the Indian audience. And in every sport, you need to understand how your body flows. So this is like a simple algorithm that I developed. It's currently open source. You can have a look at that as well. And so yeah, this is pretty much it. Thank you so much for listening to me. If you guys have any questions or any queries, feel free to reach out to me right now on my website or on LinkedIn. But before I go, I just want to teach you something. And the most important words that I feel in any language is thank you. So the next time you say thank you to anyone, you can simply sign for it. The sign language for thank you is this. So next time you probably go to a restaurant or meet somebody who's specially built, you should let them know that they are not alone. So thank you so much, guys. Again, this is me. This is the link to the slides. My name is Akshay Bahadur. That's my Twitter URL. That's my website, and then that's my link tree. So if you want to have a look at every other link that I'm on, you can have a look at link.tree/Akshay Bahadur. And thank you so much for listening to me. You guys have been great. Now, if you have any questions, I would love to take them.
I'm just curious how you're going to progress, like from using the gloves and segmentation to something more tolerant.
So if you see, so this was like an old experiment I did in 2018. My sign language work. So the videos are from that area, but if you look at this particular video, this one, so there's no gloves on my hands and I'm still able to detect it correctly. So now this is a video that I recorded in 2021, I feel, like a couple of years back. So there are more advanced technologies. But in 2018 there were less advanced technologies, plus I had a cheaper computer, less resources. But there is something called as MediaPipe, which is a library by Google, and they have these amazing capabilities where you can track hand gestures, you can track body pose estimations, you can track facial key points as well. So I'm planning to use something like this so that I don't have to depend on a glove. I hope that answers your question.
So the translation is from Indian into English?
It's from Indian to Indian language is from Indian sign language to Hindi. So not English, but a lot of the words are the same. So for English alphabets, the sign language is the same. Okay. Any other questions? Okay, if not, I think
Bi-directional? Can you go from English to a sign?
No, it's not currently bidirectional, but that's actually a pretty interesting idea to have it bidirectionally. It is currently not, but that's a good idea. I have to think about it. Thank you so much. Okay, sounds good. Thank you so much, guys.
Thank you.
Thank you.